Okay, everybody have today's packet. It should say 3.4b on the front. Does anyone have any questions they want to throw out there from Tuesday's packet first? We left off last time on section 3.3c. So why don't we turn there first today? In Tuesday's packet, the one that says module 3 fractions on the front, turn to section 3.3c and let's talk about some of that. 3.3c, all about identifying order between two fractions. How do we know whether one fraction is larger or smaller than another? And we're given the example at the start to compare 4/7 and 6/7. That we can, since they have the same denominators, pretty quickly assess which one is smaller, right? This one, 4/7, definitely less than 6/7. So less than. But then what about when we get to situations where those denominators are not the same? For example, 5/6 versus 7/9. Not immediately clear based on having unlike or different denominators, which one's smaller. Let's think back. I know some of you, this is the first time thinking through this idea. How do we scale our fractions or multiply them up to something that is equal, but with common denominator or like comparison? One thing we can do is we just multiply these two numbers, 6 times 8. Have you ever used that strategy to find that common denominator? Probably, right? 6 times 9, what is that? 54. So we could set both of these up in terms of 54. This one would obviously be multiply 9. And we would want to multiply that same number on the top to scale it or multiply the fraction up to something over 54. Over here, we're multiplying by 6 times 6. That's going to be 7 times 6, 42. Now we're talking, right? We can compare those easily. Which one's smaller? This one, 42. So sign goes this way. You kind of point the arrow at the lesser one. And so going back to our originals that we had expressed in the beginning, the 5/6 and the 7/9, let's then write down that comparison. We found 5/6 is greater than 7/9. By doing this work and seeing the relation, we can then go back and say this is how those are related. Yeah, because we're in the beginning trying to tell which one of those in that form is less, which one's greater. And so after we do a little bit of a side work, then we can make the kind of final assessment of the original fractions. The 5/6 is greater than the 7/9. Now you see on your paper that they used 18, right? Now we didn't, we used 54. How could you have used 18? Recognize that both of these multiply to 18 and then use slightly different scaling up or multipliers, right? So you've got that other reference in the example there. You can approach that kind of thing either way. Neither is necessarily better than the other, except for the one way that you understand and you're confident with, right? What? So that's a good point. If the numbers, when they're multiplied together, are really high, then that can get a little out of hand sometimes. So maybe let's just practice another one and see, can we use that other strategy? I'm just going to label these for our reference. 1, 2, and 3. Going over here. Let's compare the two fractions, 1, 8, and 3, 42nds. That's a big number if we multiply those two. So what do they share? They share a 2. What? Those both share a 2. This times 6, is that what you said? 6? That's 48. So very close. Yeah. 8 times 5 is 40. So we know there's a 2 in there. Maybe let's write down that note and write down what is left. Maybe that would help us. So if we break these down, 2 times 4, right? 2 times what on the 42? 21. 4 and 21 don't really share much. Nothing. If we took all these things that we have here and did 2 times 4 times 21, that would get us a multiple that they both go into. What is that? 1, 8. So they both go into 168. 168. How many times does 8 need to go to get to 168? 21 times. 21 times that one. And then 42 to get to 168, 4 times. 4 times. If you want to check it, you can use your calculator and do this, divide this. Yep. And so times 4 there, we get a 12. And we can see that the relation is this way. Did we save a bunch of time there? Maybe not, right? Let's do it the other way. What's 8 times 42? Without my calculator. 8 times 42 is, what was that, Dre? 336. So 336. 336. And that's times 42, we know, based on how we're approaching it this time. So that's 42 on that one. And 42 over here, 3 was on the top, times 8, 24. Boom. Did it a little bit faster, even though that's a big number. So you kind of have to be the judge of whether the kind of decisive way, the math way, really work to your benefit. Back here, it might have, with that 18, might have been a little simpler than this. But here, it gets kind of complicated. Even though that looks like a big number, it was a little more straightforward, I think. And I know that that's where a lot of us get a little disoriented in trying to decide what method or what way is best for me. So I want you to be aware of that and be looking at that throughout our problems and doing them together so that you can decide. before the test what way you're going to use, because that's important. Any questions you want to throw out there before we look at the next section, 3.4a? Mm-hmm. Whatever number we're multiplying by that 8 on this fraction to get to this denominator we want, we're going to use that same number to multiply on the top. So we had a 1 over here times that 42. This is the 42. Having a 42 here, getting it to 336 is 8 times. That fraction had a 3 on the top, so we take 8 times that 3. That helps? Okay. 3/4 and 5/7? Yeah. So 3/4, and we're still in 3/4 versus 5/7. What do you want to do? Mm-hmm. 28. That sounds good to me. How do I get there? 4 times 7. So then 3 times 7 on the top, 21. Well, that's greater. So then as we look back, we can say greater. Mm-hmm. Yeah, that's what you want to be doing. You want to be recognizing those ways that work for you. The multiplying fraction, you really want to make your life simple. Don't complicate it, is my take on multiplying fractions. It should be easy. It should be straightforward. Take the easy way out on multiplying fractions. 2/3 times 6/7 is your first example. I do not know why they have 2 times, oh, I did. 2 times 2 times 3. You can mark out the 3s and reduce. Okay, I'm going to do this 2 ways. I'm going to do it kind of like multiply and then reduce later. And then the second way around, I'm going to reduce before I multiply. This is just like the first example from section 3.4a. Multiply 2/3 times 6/7. So when we multiply fractions, we just take times on the top, times on the bottom, like this. So that's 12 over 21. And then I would need to recognize there's common factors there. They both have a 3 in them, right? So I can divide that to simplify or reduce and get 4/7. So that's one route. Call that A route. B route to multiply these. I do 2 times and then 6 here is 2 times 3, and then 3 times 7. I can try to find like things to divide like this along the way. And then I multiply 2 times 2 I have there, 7 by itself down there. You can see we get to the same answer on both of those, just slightly different way of doing so. So if you are comfortable with reducing fractions, this might be easier. If you prefer to reduce while you're working on the problem, then you might want to break down the numbers a little bit along the way. For example, this is example number 1, on example number 2, I might suggest route B. Notice it's to multiply 2/5 times 7/10 times 25 over 7. So if we go route A, 2 times 7 times 25, that's 350. 5 times 10 times 7, that's 350. That equals 1. Then we don't need any reciprocals yet, or no flipping yet. That's coming up. Yep. Route B, we're reducing along the way here. 2/5. 7, maybe break that 10 down into 2 times 5. 25 is 5 times 5. And then you can see where you might reduce 7, 5, 5, 2, all of them go away. So that's how we get 1. And if everything divides evenly, then that's 1. Number 3 on the examples says find the product. That means to multiply them. 6 times 3/4. But 6 is not a fraction. So how are we going to set that up? Find the product. 6 and 3/4. And there's times 3/4. 6 times 3/4. That's not kind of ready to go like our method over here. So how can we get it? Right, this whole number is 6 on the top, 1 on the bottom. That way you're aligned and ready to multiply. 6 times 3 across the top for 18 over 4. Then we have common 2 sitting in those two numbers. With this. So divide 2 on the 18 for 9, on the 4 for 2. So I'm going route A there, reducing at the end. How are we feeling about that multiplication? Any others on that last part of part A packet? Questions? where did I kind of magically pull out of my hat that I need to use a 2 with 18 and 4? Yeah, that's a good question. 18 is like 3 times 4 or 2 times 9, right? 4 is 3 times nothing, right? But it is 2 times 2. So when we think about those factors of the two numbers, we should land on the fact that they have 2 in common. Yeah, and that's how we get to that we need to reduce by 2. Yeah. Mm-hmm. Yeah, kind of scroll over in your head. What are the factors? We always know 1 in itself, like 1 times 18, 1 times 4, but that doesn't help us to divide 1, right? So then we go up 2 times what? 2 times 9, 2 times 2 on those. So they both have a 2. If 2 were not present in both of them, then you move up to 3, check that, move up to 4, 5, until you find something they have in common, and then you divide that out of both. Thank you for bringing that up. That is, if you have a whole number, if you want to like force it to be a fraction, you can place it over 1. You want to keep that in mind as a general kind of trick to work with fractions and whole numbers together. You need to convert the whole number to a fraction, just place it over 1. Yeah. Good question. You ready for the division? Yeah. But did you say quotient? If we see the word quotient, which which numbers are you using again? Which number? 7/8 and 3/8. Okay. Let's start with that one. What is the quotient? So we're looking at the quiz number 1 item. What is the quotient? 7/8 and 3/8. The quotient means we're going to divide them. So first up, I would just write it that way. 7/8 divide 3/8. And the immediate way that you want to change this is to say that that is equal to 7/8 times 8/3. And you referred to reciprocal earlier. That's what we're doing here. We're taking the reciprocal of that after the divide sign. So that is going on there. Taking the reciprocal. And then we use same strategy we're doing over here. So we could just divide these 8. So 7/3. I heard when you presented the question to me, some kind of like ideas about common denominator. And I want to go back to section 3.4a when I was saying, make it easy when you're dealing with things that involve multiplication of fractions. Don't bring in that stuff about common denominator. That will only be needed if we're adding or subtracting a fraction. Okay. If we're multiplying or dividing, we don't have to worry about common denominator. Quotient is division. Quotient is division. Product, multiplication. And so if you're looking at those quiz items on 3-4B, I would say focus mainly on number 2, 4, 2 and 4. Those are the ones that I would expect you to be most comfortable with. Those with the mixed numbers, go for it if you want more practice with converting mixed number. 2 and 4, definitely good practice on that section. And then section 3-4C, I want you to use at your discretion. So it's applied problems. The reason I share them with you is because they can sometimes be motivating, right? Kind of see what might be done with this stuff in context or in some kind of problem situation. So try those out. But I want to move on to 5A now, add fractions. 3-5A. So now we're going to switch gears. We're not going to tell ourselves to keep it easy all the time. We're going to have to bring in that little bit of complexity now, because when we add or subtract fractions, the least common denominator is important. Okay. So let's just look at that first example. 5/12 plus 1/12 equals 6/12. Recognize how and why we can just do that. With those numbers, 12 is the same on the bottom of those two fractions. And so we are then just enabled to operate a 5 plus 1. Now this could then be simplified. 6 has a 2 in it, and so does 12. So that's 3/6. Now both of those have a 3 in them. So that's 1/2. How many of you saw that just looking at 6/12? Because that should be 1/2 eventually. That's good. It's not critical that you see that relationship, but I just went ahead and did it piecewise, little bit by little bit. You can do it that way too, reducing. The real focus I want you to make here, though, is that that's the goal here. And so if this is not happening in the beginning, we got some kind of scaling or changing the fractions to do first. So let's look at one where we do have to do that. We've got example 2, and we've got some terminology here too, where it says find the sum. You recognize that terminology? Sum. Right. Sum means add. So like product means multiply, and quotient means divide. Sum means to add. And so we're looking at 2/3 plus 1/4. 2/3 plus 1/4, they don't agree. What's a good number we can multiply up to for 3 and 4? 12, I think that's a good one. So 12, and you want to take 3 times 4? Do that on the 2, and we get 8 for that first fraction. Similarly, do 3 here, 3 here. Keep that number the same that you multiply on top and bottom for one individual fraction. And we got 3 over 12 now on that second fraction. Now these agree, like we saw in example 1, that we can just add the top 2, and that's 11 over 12. So we just found the sum of 2/3 and 1/4. Doesn't look a lot like them, but that's their sum for what we get from adding them together. Took a little bit of scaling kind of as a second step before we could get there. So I understand that, and I know that that's a common struggle for a lot of us. My take on that, if that's how you feel, is, you know, let's be here together as many times as we can and try to make that leap so that you're getting you to where when you go home, you do feel comfortable with some of these after our discussion. It will come, yeah. How about those quiz items? Do we want to look at any one of those? We have add 2 with like denominators. I don't think we need to do number 1. We have add a whole number plus 7, 8. And then we have the find the sum of 3 different fractions. Any of those you want to see? Which one? 3 different ones. Yeah. So 4, 5, and 6. What can they all multiply up to? Any ideas? 5, 6. That's a tough one. I'll just, yeah. And so, good eye, if we look at this as 20, 4 and 5 multiply together, then we could say, what can I multiply both 20 and 6 up to? And that's 60. It's not 6 times 20, right? But we can kind of think through our table. We did a little bit of this Tuesday, where we said, okay, what are the multiples of 6? What are the multiples of 20? They're 1 time, 2 times, 3 times, 4, so forth. 10 times 6 is 60. 20 times 1 is 20, times 2 times 3, and there they match. So that's getting at a multiple that's not so far up, like 120. But you could just as well use 120 here. 20 times 6, 120. Scale all of those fractions up to 120. What's going to happen later is you're going to have to reduce that down. All right, let's go with the 60. I want to write my first fraction over 60. What am I going to do? 4 times 4 times 20 is 80. How do I get to 60 from 4? We might have to kind of dismiss or put to the side some of what we've done when we go back to how do these numbers scale up to 60. Yeah, how many times? Take 60 divide 4, 15. So then times 15 on both top and the bottom of that fraction. How about 5? How many times does that go into 60? Well, so we're scaling that fraction by 12. 3 times 12 is 36 on the top there. And this last one, 10. 5 times 10 on the top gives us 50. Now we're ready to add those. 15 and 36, then 50. What do we get? What'd you get your London? 101? 101? Just do, when you calculate 15 plus 36 plus 50, and that gives us that 101. And since we found the least common denominator here, the likelihood that we need to reduce is less. So if we tried to find like factors here, 2 is not 1, 3 is not 1, 4 is not 1, 5 is not 1. So those are actually in reduced form right there. Improper, we got the large number over the small number, but I'm not in the habit of making you convert that to 1 and 41/60. I don't really care about that so much. I'm more concerned that you get the right fraction. Leave it in that form. We're good to go. Because that is what you're going to use to do in, say, algebra or survey math. You're ready to go with that number if you needed to compute something else or graph it or whatever else. I think that one was a good one to practice. Let's look at subtracting some fractions. The 35b. We're still in that world where we need to ask ourselves whether the denominators are the same. With adding and subtracting, that always has to be top of mind. So on the first example, we have that ready to go. Subtract 9 over 10 minus 3 over 10, 0 over 10. So I do 9 minus 3, 6. And then I can reduce that. Divide 2 on top and bottom, I get 3 over 5. Let's do and focus more on this one. 2/3 minus 1/6. Not like denominators. What might we get them up to? 6. Good call, because 3 will multiply up to 6, and that's already at 6. So how do I get the 3 up? I do times 2 on that, and that's 4, and 1 gives me 3 over 6, 4 minus 1, and I'm going to reduce that by dividing 3. Since I can see both of those share a 3, And that gets me to 1/2. Any of those on the quiz that you want to look at? Don't get bogged down on the ones that involve mixed number. I'm not so crazy about spending our time on those. Like example number 3 in that section, and also numbers 3, 4, and 5 on the back. Make sure you can do one like number 2, definitely. 5, 6 minus 3/10. And any that you find similar on the Cengage website. You've got some applications of adding and subtracting fractions in the next section that you can use if you want. Then we're going to introduce signage back in. So we talked about this last week. What do we get if we multiply two negatives or a negative and a positive? Let's just kind of weave that into working with the fraction. Looking at 3/6. First one is find the product. So what are we doing? Multiplying the 7/9 and negative 3/5 together. 7/9 times negative 3/5. Okay. 7 times 3. 9 times 5. And what's my sign? Negative. Remember, going back to our thinking, odd number or negative sign shown here. The negative outcome. We didn't reduce along the way here, so we have to think, do they share a 2? No. Do they share a 3? Yes. And the way we would discover that is, say, divide this by 2. See if that's a decimal. Divide that by 2, you get a decimal, so they don't share a 2. Divide this by 3, I get a whole number. Divide this by 3, I also get a whole number. So that's what tells me I can reduce by 3. And then I write down those numbers that I get when I divide it. I get 7 here, 15 here. Don't forget my negative sign. 7 and 15, they don't share any factors. So we're done. Wow, I know. Let's try um, it's labeled as number 1, but it's really number 1 of the quotient. So that was the product. Number 1. Let's do the number 1 example for the quotient. Remember that dividing, find the quotient of -8 and 3/4. So -8 divided by 3/4. Tell me what that's equal to with multiplication. So the second one is the one we want to reciprocate. Second one, 4/3. Yeah. Yeah, after the division symbol. You were thinking we needed to take the flip of one, a reciprocal. You told me the first one then. Do it on that one that comes after the division sign. So it should look like that. Everybody okay with that? We got to be systematic and do it on the one that comes after the division sign every time, okay? What? When we have divided fractions, we want to write it as multiplying the flip of the one after the division. The divide 3/4 becomes times 4/3. And then multiply our numbers. We've got one negative, so result's going to be negative. Looks weird, doesn't it, as a fraction? I want you to get in the habit of leaving it in this form. Yeah. I know that in some past experiences, you were probably forced to convert it to a mixed number, but I'm not interested in your doing that. I want you to leave it in fraction form for right now. Let's do the quiz number 4 on this. Quiz number 4 is divide -4 divided by -6 over 11. How do we do that? Let's set up our multiplication. What's that going to look like? Good. And then this is going to equal what? 44/6, negative or positive? Positive, and why? Two negatives, or an even number of them in that multiplication operation makes a positive. And as a last hurrah here, we can check our factors and divide off a 2 to 22/3. Like which one? I will tell you that so if the problem in Cengage explicitly instructs you to report in simplest form, then 22/3 is necessary. But there are a lot of them that don't say that. And so you might be able to just enter 44/6 in that case. So we've got our signs down for multiplication and division. Let's just quickly look at it for addition and subtraction. If we wanted to add 1/3 to -5/6, in other words, 1/3 plus -5/6, what's important to start? Got to get that common denominator since we're switching to addition. This looks like something that could be scaled to 6 here. So let's do that. And then we're looking at 2/6 plus -5/6. we're ready to go and report something over 6. What is that? Two plus -5 gets us to -3. Let's pause there. I want everybody to look at those numerators and make sure you're comfortable with that result. 2 plus -5 gets us -3. Since they're different signs, we're taking the different, then the sign of the larger on the 5. And then we're going to divide common factor of 3 to reduce that. -1/2 we have in the end. I'm now going to look at the quiz item number 4. We've got subtract -5/6 minus 2/3. I want you to get in the habit of looking at addition almost exclusively with a sign. So this is equivalent to adding with a negative on the 2/3. Okay. Then we go and do our scaling to get to our common denominator here. So they're now both in terms of 6. If we do that, and then what is -5 plus -4? -9/6. Got common 3 sitting in those two numbers for -3/2. How did our strategy change at this stage? Looks like we added these two numbers, right? Notice they were both the same sign. Back here, we subtracted them when they weren't the same sign. Yeah, think about if you spent 5 and you spent 4, you spent 9. You went in the hole that much. Whereas if you spent 5 and you earned 2, then you're really kind of at a whole only down $3. Yeah. So the strategy when you're adding kind of shifts when you have unlike signs versus like signs. And so just as well as an alternative, if these were positive, 5/6 plus 4/6 equal 9/6. Positive 9 on that one. And then, 3/10. So when we have like signs, adding them, like signs here, adding them, carrying the sign with us. When we have unlike signs, we have to do a little bit of decision making. Like if the alternative here were -2/6 plus +5/6 equal +3/6, right? Because unlike signs, I subtract them, 5 is higher, it's positive here. Then my result is positive. Reduces to 1/2 positive in that case. So I want you to get situated with all that thinking on your own over the weekend. And I want you to get in that habit of converting subtraction to addition so that when you get yourself situated with all this addition, you don't need to come up with a whole nother library of thoughts for subtraction, right? You just stick to that addition. Okay. Let's do a quick take on number 5 from this section. It says subtract negative 7/12 minus negative 5/6. I want you to do that first step for me. What are we doing? Plus what? Plus positive 5/6. That's what I want you to simplify that subtraction to first. Get it to addition. Then you can scale your 6 to 12, right? And you can do the subtraction, since those are unlike signs. And you can take it from there. But that was a little bit different than this. When it's like this, we're kind of taking that subtraction and tacking it on. When it's like this, we're using this subtraction to combine with that negative, and it just becomes positive. Like, think about it kind of like multiplying two negatives there, makes it positive. So you fill in the rest for something like number 5 there. It's like number 15. Number 5. You can work on that. And let's look at order of operations examples for a moment. First example is negative 3/5 squared divide negative 1/3 minus 4/15. Remember, our order of operations is parentheses, exponent, multiplication and division, and then addition and subtraction. 4 stages. And looks like we have parentheses here. So let's focus in on these parentheses first. We can convert this to plus what? Negative 4/15. Then let's also scale that first one. What can we multiply on this to get it up to a common denominator? A 5. So 1 times 5 on the top gets us to 5/15. This has a negative on this one. Then what are we looking at after that? Negative 9. Like sign. What? Sorry, I didn't hear. We can leave it or reduce it at this point. We're not going to take the reciprocal of the one in front, remember, and do the one after. London, about your question, what we do with this simplifying it, you be the judge. So maybe it helps to simplify it, maybe it doesn't. Let's leave it there for right now and see what happens over here with this exponent. Now that we're done with that set of parentheses, kind of, we haven't quite simplified it. But let's just do this exponent. Negative 3/5 times negative 3/5, right? That's what that means. Take whatever is right before it and multiply it that many times over. 9/25, positive. 2 negatives make that positive. So then I'm just going to bring down this division sign between these. Is they okay with where we are? So then 9/25 and what? What do I do over here? The times what? 15/9, and this is negative. You can place that negative wherever you want in there. And then looks like because we kind of left it in that way, that's an easy division here. Yeah. If we have reduced this to 3/5, we can still work with it here, but we wouldn't have that available to just divide straight away. What's our sign on the result? Still reduce. We need to take 5 as our note here. Yep, 5 goes into 25 5 times. So we've got 3/5 remaining. I want to come in here and also just write down that in case some people don't want to do that simplification within. You can write it down like we had it, 15/25, and then do your reducing in the next step to 3/5 if you want. Either way is fine. Don't forget that negative sign, right? You got a positive times a negative, that's going to result in a negative. Got a lot going on right there. Any questions? Are we good with that? So just continue practicing on that section. I know that one's going to be probably the most challenging because notice what we just did there. It involved everything we talked about today, right? Subtracting fractions, multiplying fractions, flipping them for division, signage, everything was embedded in there. So just do your best on that section. I want to quickly end with a view to how do we simplify complex fractions? In other words, a fraction with 2 fractions in it. Like example 1 here, we have 1/3 over 2/5. It's the way you can read this, kind of like it from here down, 1/3 divided by 2/5. And then it becomes a division problem. Let's multiply the flip and then multiply. I would focus your practice of that section on number 2 of the example. Number 3, a little complicated. Maybe look at Cengage for some better examples than number 3. But practice number 2 for yourself. Self-practice number 2. I just want to give you one more of these, suppose I had, the next, for example, 2/7 over -8/9. So we read it into a division problem, 2/7 divided by -8/9. What's that going to become? 2/7 times the flip of this, and then multiplying it, I get -18 over 56, and I can reduce that to -9 over 28. So that's taking that 2 out there. Just one more example, and see that we had a sign in that one. So that kind of carries through. We write it as division, convert it to multiplication, do our multiplication. We've got one negative in there, so our result is turning out negative on that one.